Alright, let's analyze this one first. Equally charged. So that's kind of key. We've got a force, we've got a distance, but do we roll in centimeters? No, this is going to be 0.291 meters. What else here? I think everything's okay. Now here's the deal. If this is F, electric force, equals K, Q1, Q2, R squared, I can turn that into K. They're equally charged. So wouldn't this be Q squared over R squared? And I'll solve for Q. Q is the big unknown here. Question mark. Alright, so let's set this up. I'll rewrite this for fun. Equals K times Q squared. Q1 times Q2, and they're equal, would be Q squared over R squared. Alright, so what we could do, let's just solve for Q squared right away. R squared both sides. You're gonna have to kind of just take my word for it here. It's going to be force electric times R squared. That's a squared, believe it or not. And then I got to divide that K out of there. So okay, so let's do it now. Q squared, which I'm going to square root at the end, yes. My force electric, didn't they tell us that was... Let's leave that negative off so we don't have to deal with a negative square root. Just a direction indicator, meaning, you know, push or pull or attract or repel, whatever they're talking about. And then my R was 0.291 meters, but don't forget to square it. And then my K is 9.0 times 10 to the ninth, and that's Newton meters squared over Coulombs squared. So let's throw this thing into our calculator. Give me some room here. And I will go, follow along with me, 0.492. I'm going to multiply that by 0.291, but be sure to square it. And then divide by 9, EE9. And I get some craziness, and then you go square root answer, and I'm going to get 2.151 times 10 to the negative 6, and that would be coulombs. Probably don't need the 1 after the 5 there, but 2.151 is Q, and since both Q's are the same, it'd be both Q1 and Q2, yes? Woo-woo, woo-woo.